Thanks to Sonia, Daniel, Juan, Oscar, and all the team at Geo Oil Energy in Colombia to invite me to present today. And thanks for attending this presentation to all of you that are online. As Oscar, I think, said in Espanol, I've been involved in delivery of onshore and offshore satellite and airborne solutions to the energy sector in Colombia and around the world for 30 plus years. So I appreciate your attendance today. And today, while we have many other applications at MDA that use satellite imagery, I'm going to focus on our solution that we deliver to the offshore portion of the energy sector, where we're tracking oil on water. So we call it Oil Tracker, and it's a satellite monitoring solution that you'll hear about today. So just a quick commercial on MDA. MDA is Canada's premier space company. We've been incorporated in Canada since 1969, and we have many different technologies that have been involved on such missions as the shuttle program, telecom satellites, the International Space Station, Mars rovers and landers, and many other different missions, including RADARSAT-2, which is what I'll focus on today. So we build these sensors, we participate in the launch, and then we collect the imagery back to the ground, and then we process it, analyze it, and produce information for our customers. There's 3 divisions. I'm not going to go into details here. I sit in the geointelligence division, and you'll see here the RADARSAT Constellation mission, which was launched recently. MDA built that series of satellites for our Canadian government. You'll see the space station arm here, Mars landers, our staff at work building satellites. So we're involved heavily into that kind of work. Our focus is on space, and we have been involved in this for over 50 years, 40 years on the Canadarm side of things and 30 years on radar satellites. So we are a leader in this sector globally. So I'll talk about the Oil Tracker solution today and give you some industry use cases, tell you how, and you can ask questions about how we get the analysis of the oil slicks from the synthetic aperture radar. And I'll just describe the commercial side of things briefly for you, how we have different service tiers that apply to different customer needs. And then a simple snapshot of what the product deliverables look like. And I'll give you my contact information at the bottom, but of course, Oscar and team there know me well and can connect you with me after the fact. So how does synthetic aperture radar work? How do we actually see oil on the water? So really, we're not seeing the oil like you would on an optical image. What we're seeing is a dampening or damping effect on the ocean surface. So the ocean surface is rough to a radar microwave beam. So it sends out a beam, and then it reflects in different directions off the ocean waves. But if the slick is flattening the surface of those capillary waves, then it looks black. And that's what you'll see on this imagery that I have to show you today. If it hits a platform or a ship, that's a metal target to microwave energy, and it bounces back very, very strongly to the satellite. The satellite's at 800 kilometers altitude in orbit, and it orbits the Earth in a polar direction. So there's opportunities to collect imagery on an ascending, so we're going north, or descending paths. So we can point the satellite as well to different areas. So this allows us to produce broad area offshore monitoring, and the satellite is really covering large areas. And we don't have to deploy anything on the ocean. We're seeing everything remotely. It is truly remote sensing. And I'll describe some of the different beam modes. So we have complete control of our satellite, RADARSAT-2. We change the beam modes to focus in on small areas with a small track, or we can make it large areas and cover huge areas of the ocean to look for oil slicks or for ships. And maybe sometimes the ships are transponding and sometimes they aren't. So we do ship tracking with RADARSAT-2, when we do oil slick tracking. And the driver for the use of this imagery in the energy sector is to get that first image as fast as you can in response to a spill. That's one case where we do encourage routine monitoring of offshore assets, because that helps us get that first image earlier than if you just kind of phone the hotline at MDA and say, I need an image over Colombia, offshore Colombia or offshore Panama. It's a slower process. The satellite may not be in the right position in orbit. So we suggest that you do routine monitoring over your assets, and then we're able to get that first time to image down really, really low, same day, next day type of response. So we're using this spaceborne synthetic aperture radar technology, and it's a proven tool. There's a number of satellites on orbit. We use a variety of those radar satellites, not only just RadarSat-2, which is our own. We've built other satellites. We participate in other programs with the European companies. We worked with the Japanese companies and the Argentinian companies, et cetera, that have synthetic aperture radar satellites. Okay, so radar, what's good about radar is we're seeing through the clouds and fog, and it images day or night, right? So we're not restricted by cloud cover at all, like an optical satellite mission would be. So we're seeing these portions of the ocean very regularly and predictably. We can program the satellite and we're going to get that picture of the ground or of the ocean. And then of course our products are easy to consume and bring into your GIS systems or your image processing systems or other analytical systems. Here's an example of a high resolution radar image. This is a 5 meter, what we call extra fine image. The swath width, it may not show the entire swath of the image here on this snapshot, but we're showing up to 125 kilometers in the swath and 5 meter pixels. So what you're seeing here is the loading facility of Baku, Azerbaijan, and platforms, production platforms that are having some oil come off of them. There's quite a bit of oil in the water here, and this is kind of what the loading facility looks like, this portion of the image. So you're seeing quite a great detail. The ocean surface was just ideal here. I'll talk about imposters and problems that we have with radar imaging later, but in this case, ocean state was perfect, not too windy, not too calm, and the signature from the different platforms and the oil slicks are very clear. All right, we're trusted by the energy community. We delivered many, many images to BP during the Deepwater Horizon incident. We can create these, I'll talk about this a little later, these wind maps directly from the radar sat imagery. So we were trusted by BP during that whole spill incident. Here's an example of spills in Bohai Bay, China. Another example from another major operator in the North Sea, where there was a smaller spill. Then of course, Macondo was the largest we've seen in our lifetime, of course, but these other ones were smaller ones. So we had a spill response off Brazil, off Nigeria, and again, back up in the North Sea. In this case, it's kind of interesting because this spill was not just oil, like crude oil. It was actually condensate showing up temporarily on the surface of the ocean during a gas incident. Okay, so we have an analysis team that processes over 1,000 of these types of images per year. We have a true 24/7, 365 emergencies support hotline, and we're repeatedly selected for these kind of international monitoring programs. What does it look like in an ideal situation? Here's a case where we had a response. The customer was already signed up to monitoring, which I mentioned earlier is a key. So that our satellite is tasked, or satellites, we can task multiple satellites if you choose, over your assets. And then that means that we can really quickly respond. So Oil Tracker service is established, we're monitoring. There's a consistent archive with a specific beam mode that is, the beam mode is that resolution versus swath decision-making that we do with you, the customers. And then an incident occurs over the AOI, and within, the client contacts our hotline. And then we had these preset acquisitions able to respond. And that meant we had same-day delivery of the first response imagery. So within 5 hours of the customer notifying us, we had an image in their hands available for their responders. Here's the snapshot of what the Deepwater Horizon slick looked like early on in that incident. And I'm going to go through how we do the categorization. We still do this manually. We've tried ML, we've tried AI. We don't like it. We do it manually. And I'll tell you why as I go through here. Because there's a lot of slick imposters in reality. So is this a slick? We don't know. This is a slick. We know that. So we have, at first step, is we screen all of our imagery. So that we might have hundreds of images that we would screen, and metocean conditions have to be of a certain range. I think it's 2 to 12 meters per second, something like that, for it to be a perfect situation for radar to detect oil and water. So we do a screening initially, and then we start oil classification. So we look at the signature, the morphology, the detectability on this kind of triangle. And I'll show you how this works in a minute. And then we classify the slick as to potential source and the likelihood that it's either pollution, a seep, or unknown. Okay, unknown source. Here's what the metocean type of work looks like. Here's the raw image, a classification of the wind direction and speed, and then some areas where the slick is actually damping the surface, so we can make sure that it's going to be an effective oil slick mapping exercise. So we have different types of oil on the ocean surface. And of course, there's, we call it pollution in this case, but it's really oil slicks on water, and they can be from a number of sources. I'll show you what those look like from the various sources. We can have natural hydrocarbon seeps. This is oil, not natural gas, okay? To be clear, we cannot detect natural gas at the surface, typically. That one case I showed you had high condensate, wet condensate coming out of the well. So we were able to detect that particular natural gas incident, but don't count on radar to be able to detect natural gas. It's oil that we're looking for, okay? Crude oil, natural hydrocarbon seeps, and in this case, pollution from a variety of sources. You know, you can read this. This slide deck will be made available to you. It'll show you how we go about the classification. And I should comment that we've tried the machine learning, we've tried the AI. There's a variety of sources, including our own attempts at doing this. And we spend more time on the quality assurance and removing false positives than we do by just delineating the actual slick ourselves. Here's a good example. We have a ship going through an area, and that's a 1P. That's really an obvious pollution event. The bilge is being dumped. There's a slick, and the ship is here, right, as a small white target down here. It's turned off its transponder, perhaps, and has dumped its dirty bilge, and here it is going to the northwest. This is not oil. This is actually a storm system with calm water underneath a storm, okay? So that's one of the imposters. Here's another example. We know this is pollution. We can see the bright target from a platform, a ship, other platforms in the area. And then we can reliably classify these as oil slicks from a particular source in an area. This one maybe gives us a little less confidence. Okay, here's a storm front along here. Then less confident again, so detectability, very highly detectable as a 1P, 2P, and then 3P is less confident in terms of the signatures that we're seeing. Here's the oil, here's some storm activity, more storm activity, and a ship with a bilge dump probably in this area. So I'm not the expert analysis person. I know how they do this, and I'm kind of giving you a snapshot of how we go about classifying oil on water in our radar imagery. Natural seeps have a very characteristic shape and edge, weathering edge and shape. And if you take multiple images, sometimes we'll do 200 or 300 images over these slicks and actually create a rose diagram or a cluster analysis that would, over time, your wind would change direction. So the seep might manifest this way, it might manifest this way or here. Over time from the radar images, we can see the source location for natural seeps based on a very high, large stack of images. So this is a very obvious natural oil seep for us in radar image. Some less obvious ones might look something like this. And then we have the effect of, you can see some very wet clouds where the radar isn't penetrating through the cloud in this case. These things are just moisture laden in the tropics somewhere. So sometimes even radar doesn't penetrate extreme weather events. But here's where we get a kind of a dispersed seep signature that we put down in a lower probability category. And then we go into our unknown, like where did this oil come from? We're pretty sure this is a slick on the water, but in this case, we're not sure where that came from. It didn't come from this dot, which might be a ship or a platform. It just is there. So we're not really confident that it's an unknown. Okay, we're not sure of the source. These ones a little more obvious that it came from this ship or platform or this ship or platform, but this one is a bit anomalous. And then finally, we have some examples of where it looks like oil. We're not going to bet the farm on this being oil, but it's a possibility that would have to be investigated with other methods like a ship or notes from those platforms as to what that original source might be. Then we get into some really strange things like perhaps coral blooms. Coral blooms might look like oil on water. There might be algae. Sargassum in the Gulf of Mexico is an example of that, where there's massive blooms of algae, and they can be slick imposters. So we're thinking maybe that's what this is. So we put it down in less likely. There's also a number of other slick imposters, as we call them. So this is where the skill, the 20-year experience comes in from our analysts, and the multi-imaging of a site is really important, because you might have some wind shear coming through that obliterates your signal of your slicks in an area. You might have really low winds. So what is this? It looks, well, it's probably just calm water. There's other rain cell effects where you have very calm water and it appears black, and then you have high winds where you can't see anything over that 25 meters or 12, 15 meters per second type of wind speeds. You can even have turbulent wake through a rough sea that looks like an oil slick or a bilge dump, but it's not. And then you have freshwater plume effects from the effluence of natural waters coming into the ocean. So there's a number of things that we really, really watch for and that we're experienced in identifying so that you don't end up with erroneous interpretations. And we do work carefully with customers through all of this to make sure that our interpretation matches with their expectations. So there's a variety of ways that you can actually subscribe to Oil Tracker. We have a basic service that's quite inexpensive. We have an on-call service, which a number of customers subscribe to, which means we acquire the imagery and it goes into an archive, and they have the 24/7 hotline if they need it, but we don't really do too many Oil Tracker reports. There's a rapid alert scenario where we deliver reports weekly, monthly, even less than weekly in some parts of the world, and we might use multiple satellites to do that. And then the complete scenario is when you're really concerned about a cluster of production platforms or assets offshore, and you really need to know what's going on with the oil on water, whether it's natural seeps or bilge dumping near your platforms, or your platform leaks. Are we completely monitoring those areas carefully? That's where the complete program comes into play. And then of course you have the ability to program for an emergency event. If you're subscribing and under contract with MDA, then you can access the hotline and access our specialists for emergency programming and also interpretation. So it makes a big difference in terms of the timing and delivery of our service. And here's what the service looks like. So we can deliver via PDF. Some of our customers really like this because they can just pull it up on their phone if they're responding to an incident, or they're checking something out in a helicopter and they're flying by to see what it is, or they're actually sending out a different asset like a UAV or an airplane to have a look, helicopter or airplanes to verify what these slicks are that might be coming at your platforms. And then, for seep analysis, there's that whole exploration piece that I haven't spent much time on. But this kind of delivery, PDF, KML, or shapefiles into your GIS allows you to actually see where that oil and water is in relation to your assets, which you would have in a GIS. And then, of course, the GeoTIFF, a snapshot of the actual radar image, so that it's smaller and it's compressed and it fits in your normal GIS system or handheld equipment. Then you'll be able to see what it looks like on the radar image as well. So we have this these are our standard offerings. And then finally, of course, we deliver that wind map. So it shows you where we expect this oil to be going. And as you know, the current side of things we do not do, but we do the wind derivation from the radar, and it shows you a direction and speed on that derived product straight from this synthetic aperture radar image. So that's all I have today for you. And I will, let's see, I can stop the share and have a look at the chat line to see if you've got some good questions. Happy to answer.